Alright, welcome to Unit 3. First unit was just on polynomials and adding, subtracting, multiplying, and long division. Now we're looking at, we looked at factoring, which is necessary for dealing with rational expressions. Again, rational expressions are fractions, so we're going to be looking at fractions a bit. So let's look at this. Simplify each and state the excluded values. There are more than one example, that's why it says each. And excluded values we'll talk about in a second. So simplify means to find a equivalent but simpler fraction. These two, the numerator and denominator, have a GCF of 20x squared. So this can be written as 20x squared times, not 20x squared, 10x squared. They have a GCF of 10x squared and 10x squared, and the remaining parts at the top would be 5x squared, and the denominator would be 2. So these cancel out. 10x squared divided by 10x squared is equal to 1, leaving our final fraction to be 5x squared over 2. Now these things are not exactly equal. If you plug in any number here and any number here, we should get the same value. For instance, 50 times 1 to the 4th power over 20 times 1 to the 2nd power, which is equal to 50 over 1, or 20, or 5 halves, should be equal to 5 times 1 to the 2nd power over 2, which is also 5 halves. Now you would say those two things are equal, so these fractions must be equal, and you can plug in any number. With one exception, there's one number you cannot plug in where these two fractions are exactly the same. That brings us to this little blurb here about excluded values, and that is that in the original fraction there's one number you cannot plug in here, and that number is 0, and the reason for that is 50 times 0 to the 4th power divided by 20 times 0 to the 2nd power is actually undefined. What does this want to write? Alright, I froze here. This is undefined because it requires you to divide by 0, and division by 0 is not allowed. Whereas when we plug in 0 here, this is equal to 0. These are not the same thing. 0 means having nothing, whereas undefined in this context means something else. Let's look at undefined for a moment. So the correct simplified expression here is 50x to the 4th divided by 20x squared is equal to 5x to the 2nd over 2 when x not equal to 0. So when x is not equal to 0, this is equal to this expression. Why is division by 0 undefined? Let's look at division for a second. We have 3 divided by 2. That's the same thing as saying we have 3 objects. We take them in groups of 2, so that's one group, and a half a group, which is 1 1/2. But if we try to divide by 0, 3 divided by 0, that is 3 items in which you can take a group, a group, a group, a group. You can take infinitely many groups out of here, but you'll never actually get anywhere, which is infinity. That's why some people think that it's infinite. Another explanation for an expression like that being undefined comes from our calculator. I think I can get the calculator open here. Whatever, we'll just take a look at this idea. X over x should be equal to 1, but it's not, it's undefined when x is equal to 0, so it's 1 at all other points. So if we check a value that's close to 0, like, I don't know, 0.00000 over actually let's change that a little. Let's say we have 1 divided by x, so when x is 1, this is equal to 1, so when that's the same, this is when x is equal to 1. If we have 1 over x where x is equal to something really large, like 1,000, let's even say 1,000,000, that's approximately equal to 0, something so small. But if x is equal to something, let's say, really small, like 0.0000000000001, that's something that's really large. Let's say it's approximately equal to infinity. So it has like 3 different answers for what division by 0 is. Well, it's approximately equal to infinity. So that's 2 reasons why it's equal to infinity. But we call it undefined, and that's not really the purpose of the video to explain why division by 0 is undefined, but do know that 2 fractions can't be equivalent if one of them generates an undefined value at a number and the other one doesn't. So this is not equal to 5x squared over 2. This is equal to 5x x squared over 2 when x is not equal to 0. So they are the same in that case. So let's look at another example. These are binomials, so factoring them is a little, I guess it's easier in this case because there's more specific value you'd factor out. These have a common factor of 10, x to the third, and that would leave over an x squared minus 5x squared minus 4, and this has a GCF of, what can be divided out here? It goes into 50 and 32. I don't think anything does, so it's just x to the second in this case. No, just x. Leaving over a 50x minus 32. So in this case, these have a common factor of x, so x cancels out with one of these x's, leaving a square over here. Now, this expression is actually undefined for 2 values. One when x is equal to 0, and one when x is equal to, this is 32 over 50. But this is a simplified form. Because this x cancels out, we have to include that this fraction is the same as this one when x is not equal to 0. So the final answer should be 10x. Actually, we would have to multiply the remaining pieces back together. So once we cancel this out, the x cannot be equal to 0 anymore. So this is a 50x to the fourth minus 40x squared over 50x minus 32 when x is not equal to 0. Alright, so let's take a look at another example. It looks similar. I don't know if this one's going to work out so well. I had a plan for it, but I don't want to look at it because I don't think we accomplished it. I don't think I wrote this problem the way it was supposed to be. So let's change it a little bit. Let's say we had x squared minus, not that way, x squared, 9 minus x squared over x squared plus 5x plus 6. That's more along what I was looking for. So to simplify this, we have a factor that's going to be equal to 3 minus x. Keep trying to write x first, but I know that's wrong, so I'm going to stop doing that. 3 minus x and x minus, I'm doing it again, 3 plus x. And this one will have a x plus 3 and an x plus 2. Alright, so we cancel these out. Negative 3 is suddenly made this undefined before, so our final answer would be 3 minus x over x plus 2 when x is not equal to negative 3. Alright, so these two expressions are equal, if you mention this. Alright, because negative 3 was not an option here, so it should not be an option in its simpler form. Alright, so one more example over here, because I didn't get to address it, which I was trying to do. I'm going to change this slightly. So let's erase this. And it's this idea. Let's actually erase just that negative, this positive. It's supposed to be negative. Same problem. Simplify and state the excluded values. This again is 3 minus x, not x minus 3, and 3 plus x, not x plus 3. Actually, in that case, it doesn't matter, because addition is commutative, but subtraction is not. This will now factor to be x minus 3 and x plus 2. Alright, so in this case, the question is, does anything cancel out? The truth is these do, and the whole purpose of this problem was to indicate that when you cancel out two opposite signed polynomials in this form, you have a negative 1 left over. And here's the reason for that. If we factor out a negative 1 from here, that's negative 3 minus plus x, which can be rewritten as negative x minus 3. So, looking at it this way, you can see why canceling these opposites would generate a negative 1. So that's now negative 3 plus x over x plus 2. By canceling out this denominator, we've eliminated negative 3 as a possible entry into this expression. So our final answer should be negative 3 minus x over x plus 2. Oh, excuse me. I made the same mistake. When x is not equal to negative 3. Alright, so it has an excluded value, and it had to be simplified. One last example. Alright, so this is just a heavy factoring example. The GCF here is 3x to the fourth, which will leave over an x to the second, a negative x to the first, and a negative 12, just negative 12, all over, this is a GCF of 6, x to the second, what is this, x squared plus 8x and a 15? I want to say 15. 15. Alright, so these can be factored further. So that'll become 3x to the fourth. This is x minus 4 and x plus 1. No, x plus 3. Over 6x squared, x plus 3, and x plus 5. So this is where we're going to notice what our excluded values become. One, these two x squareds cancel out with two of these. So there was a 0 that can no longer be a value in this simplified expression. That would have made it undefined, so x is not equal to 0. In addition to that, when these cancel out, negative 3 was a value that would make this undefined. So the new expression will not be made undefined by negative 3, so we have to exclude it. So negative 3 is also a non-included value here. Alright, so our final answer should be by distributing this out and distributing the 6 out. Well, actually, the 3 and the 6 have a common factor. 3 goes into 6 once, and 3 goes into 3 once, and 3 goes into 6 twice. So distributing out that 1x squared, the numerator here will become what's that? X to the third minus 4x over 2x plus 10, where x is not equal to 0 or negative 3. So that would be our final simplified expression, including the excluded values in our answer.